All right, guys, as you can see, we have a good project on our hands today. So, what we are going to be doing is something that I've wanted to do for so long. Probably since about the time I started this channel, I've wanted to do this project and just never really got up the nerve to do it. But today we're going to try to tackle this. If you guys know what these things are, then you know where we're going. But if not, what we're going to be trying to build today is an automated irrigation system for your backyard, or in this case, my backyard. What I have here are three, and I picked these up just at my local hardware store. These are solenoid valves. So if we apply power to them, they let water through, and if we take power away, they shut off. So we have three of them, and eventually they will connect up to this manifold that I bought. We got our three valves, and I have three corresponding relays. One will control each valve. I have my ESP8266 node MCU. Yes, guys, I have finally listened to you, and I've bought a couple of these guys here. I avoided buying these node MCU, Wemos, whatever you call them, modules, for a very long time. One, because I like building things myself, and two, because previously when I looked on eBay, I saw that they were $5 or $6, and for $3.50 I could have an ESP and a little power circuit, so I just went with that. But I recently found these as low as $3 on eBay, maybe even $2.80, I think. So I went and I bought a whole bunch of them. So really, I hear it kind of works. It comes down to, I like to do it myself, but if the price is right, the price is right. I also have a little 5 volt. This is a 120 to 5 volt AC adapter. So that will power this guy. And then to power these, I have a big chunky 120 volt to 24 volt AC, which is what these guys run on. So our relays will be switching the output here, the 24 volts. Along with that, I got a little capacitor here. This is just for cleaning up my input power signal. I got some assorted 1K resistor relays because I figure I'll need them somewhere. And I got a couple of little tactile push buttons. Now, one of these push buttons is going to be a test, so it will trigger all three of these to run in succession, just so that I can test everything. And the other one will be a manual start for the irrigation system. Now, my goal here is that this will all be attached. I have this, actually, it's an old cutting board that I've put everything on. And my goal is I'm going to zip tie and attach it to this cutting board here. And hopefully by the end, every morning at 6:30 a.m., these will all trigger in succession, thus watering each part of my lawn. Now, you might ask, well, why not just have one and water the entire lawn just through using a splitter, a manifold like this, and have the solenoid valve at the beginning, at the start of that? The reason is that there's just not enough water pressure in my house to run 3 full sprinklers going to cover the entire yard. So I'll have one trigger, then the next, and then finally the last one will trigger. So hopefully those will be at, I don't know, maybe 20-minute increments per section of lawn. You know, I'll tweak the numbers as I go. This is a project that we're doing from full start. I haven't done any prepping, any planning on this other than to go buy all of this stuff. Now, this is not the cheapest way to do this, probably. Let's call it around $80. Might be $90. It's relatively cheap, but probably not the cheapest thing possible, but it's what we're going to go with today. So, my first plan of attack here is to get my ESP module, my Wemos here, hooked up, get power running to it, and get these 3 relays connected to 3 pins on here. So we're going to start with that, and then we're going to work on the solenoids, and then finally maybe put these little buttons in here and we will see if we can get everything just to run in a test bed state. So with that, let's start with the Wemos Node MCU ESP8266, whatever you want to call it. All right, so the first thing that I want to do is I want to get this little guy here, this little 120 to 5 volt adapter. I want to get this wired up so I can at least see that the power is working on the ESP module. So what I've done is I've taken the end of a plug that I don't need anymore, some light or something. Now I've already taken it and connected it to my transformer here and with these little wire nuts. And I've also split off an extra little cable that will go and be soldered onto this guy here. And then the output of this, I will hook up to another little wire that's got a couple of little header pins and just plug those right into this breadboard, and we'll be able to at least test and make sure that our 5 volt power here works. And then I will take a couple of wires on here, run them out to my 3 relays. All right, so there we go. Got that all wired up. Hopefully now when I plug it in, we won't have any sparks. So let's see. Oh, beautiful. Look at that. The little blinking light from the default firmware on the Node MCU is blinking away. Now the next step is to get these 3 relays wired up and ready to go. For these relays, the plan is we're going to connect up to 3 of the digital pins here on the Wemos. So I have chosen to use pins 5, 6, and 7. So we're going to I got some wire here that I've already pre-tinned, and hopefully we will then be able to at least give sort of a test of the functionality of our relays. And we won't have a full test of our system yet, but we'll be able to test our relays out at least. So let's get to it. All right, so there we go. We got all 3 relays hooked up here. We got them hooked up to power. Now we can actually get this to test. And I do see green lights across all 3 relays. And if I take my signal pins from each of the relays, go to 5 volts 1, that turned that one on. It's to the next one. And 5 volts to the last one. And that one turned on. Perfect. So we now have a successful test of all 3 relays. We've got... Whoa! So, that was stupid of me. I just grabbed this. Nothing like a little 120 volt shock to wake you up. Damn. All right, so first order of business here. Wrap this sucker in electrical tape. Not having that happen again. Let's unplug. Huh? That seems like a good idea. So, next plan of attack here, I am going to try to clean all this here up. I'm going to take some zip ties. I'm going to drill some holes in this. And we're going to get kind of all this stuff strapped down. And next time you see this, hopefully it'll look a little bit cleaner. And we can start hooking up our solenoid valves. All right, and just like that, look at this. Everything beautiful. Even here it kind of works. I occasionally like a little bit of cable management. So I've got my 5 volts. I've got my transformer for my 24 volt AC, my ESP module, and my 3 relays all hooked up beautifully. The only thing that I have changed here is my 5-volt line coming in is now only powering this power strip here. So over here, this I will have not done yet, but I will be making this into the 3.3 volt side for my little buttons. But right now, all I've done is I've taken my V-in wire here and just connected it to this side. So now the module powers up. I've got my 3 relays, all this, and look at that. I even managed to wrap my 5-volt power supply in electrical tape. With this done, what I want to do now is take I have some 4-core wire here, and I'm going to take the black wire, and that's going to go to one of the connectors on my transformer. And then the other connector on the transformer will go to the common of the 3 relays. The output of the 3 relays, or the normally open connection, will go to one of these 3 wires here. So when I trigger each of the relays, each of the solenoids, whichever one is connected up and is triggered on the relay, should open and allow water to pass through. I'm going to get that wired up, and then we'll be on to the next part, which will be taking a look at some of the code. All right, so I got the wiring all set for the control board. So now I've got my 3 solenoids here with their 3 wires, or their 6 collective wires. And what I'm going to do is, remember there was that common wire that I had, the black wire from my cable? What I'm going to do is I'm going to take one wire from each of these solenoids and connect that wire, all 3 of those wires all together, and connect them to that black wire. All right, now with that set, we have 3 cables, 3 little wires left, our red, white, and green little wires here. And each one of those is going to connect to the subsequent wires that we have left coming from each of our valves. All right, there we go. Finally, it's all together. This doesn't look kind of sketchy whatsoever. Let's go now and run a little test just to make sure that everything works, and then take a look at the code that is going to run all of this. Forgot just one thing before we actually go and get this testing. Forgot to put in my little buttons here. Before we go any further, I'll just quickly get those whipped up with some little pull-down resistors, and we'll be ready to go. All right, we've got this all set up finally. Now, let's go ahead and test this out. Okay, well, I really just couldn't help myself when I sat down to start writing this code. The whole program came out of me. So, no testing here. We got the whole program, and we're going to go through the whole thing. So, up at the top, we have ESP helper, Metro and time library, and the networking UDP library. Just helps us keep track of timers and the actual real time. Bounce library. So we set up a couple macros to basically set milliseconds all the way out to hours. And we define all of our pins. So we have our relay pins, our button pins, and the debouncers for each of our buttons. And then we come down here, and this is really the only code that you'll have to change for your own setup. So we have a section timer and a cycle timer. So I have 3 sections. Each section will run for 15 minutes. And we're going to trigger every morning at 6:30 a.m. with the time zone of -4. ESP helper here, all this stuff, you guys have seen it before. OTA passwords, your host names, all of that awesome stuff. You guys know how to set that up. We have some more variables for the NTP time synchronization. You really don't have to worry about those. And then we have a whole bunch of variables here for keeping track of the current state of the system. So run cycle and has started. Those keep track of whether or not we want to or are currently running a cycle. Mode basically keeps track of which valve is currently open. Skip next will let us skip an upcoming watering cycle. Test running is similar to run cycle, but just for when we run our little test function to make sure that all the valves work. And we have our button states, and init done will keep track of whether or not we've synchronized with the time servers. Under that, we have a few little metro timers here just to keep track of how far into various cycles we are. So in setup, we set up all of our pins as our relays as outputs and set all the valves to off. And our buttons, we set those as inputs and attach them to the debouncers. ESP helper setup, it's pretty basic. And the only thing that we have that's kind of special here, we have a subscription to the callback topic, which will be a topic that we can send a value to either skip or not skip an upcoming cycle. A couple more little bits of setup just to get our NTP time synchronization set up, and we are into loop. So once we're in loop, we make sure that we're connected to Wi-Fi, and as long as we are, we then check to see whether or not we've initialized our time synchronization. If we haven't, we make sure that we synchronize with the time servers, and then we move on to the rest of the loop. The rest of it, once we've initialized, we update our buttons on our time, and either button 1 or our time will trigger a full cycle to run. So we reset our section and cycle timers and set run cycle to true. Button 2 will trigger the test to start. So this just is a kind of a mini cycle where we open each valve for 30 seconds each. We have one last little else if here that keeps track of things for cycles, which is basically a way for us to disable the skip next. If skip next is true and we have passed the hour and minute of our trigger, then we reset skip next to false, and that just resets it for the next day's cycle. Coming down a little bit further, we have a check-in here for the cycle timer, and this is just one of the little interlocks that I have to make sure that we don't continuously run and have valves open. So if the cycle timer has run up, then we set our run cycle flag to false. Otherwise, we just check whether or not we're running a test or not, and run either run test or cycle handler, depending on what we're trying to do. So in cycle handler, we basically have 3 sections. A section that triggers a brand new cycle to start, a section that triggers an existing cycle to end, and a section that handles mid-cycle valve changes. So when we want to start a cycle, we set has started to true. We set our mode to 1, which is basically opening up the first valve, and we reset our section timer. When a cycle is ended, we set has started to false and set all the valves to off. In the middle of a cycle, we check our section timer, and every 15 minutes or whenever that timer goes off, we change our mode. So we change which valve is open. And as long as our mode is less than 4, we set the valve to whichever value mode is at. So valves 1, 2, and 3. If mode is more than 4, that means that we've run all 3 valves, and we basically are going to end a cycle. So this is another way for us to stop a cycle. We set has started to false, reset all the variables for the next cycle. Run test is very similar to the code in here. We have a timer that goes off every 30 seconds, and as long as the test state, which is like mode above, as long as that is less than 4, set our valves, and if it's more than 4, then we've run all 3 valves and we turn everything off and reset for the next time. We have a set valve function here, so this just lets us set whichever valve open that we want to have open and all of the others to off. At the bottom, we have one last catch-all, which basically any value that is not numbers 1, 2, or 3 will set all of the valves to off. So again, another way to just make sure that accidental programming doesn't leave any of the valves open and running. You'll notice that throughout the code, there is this post timestamp function called all over the place. And really, basically all this function does is take a string that you want to post to an MQTT topic and append the timestamp to that as well as the host name, so that we can keep watching it. We can monitor what's happening with the system. So that's all that this does. This function here actually creates the timestamp string and is used in this function here. Everything else down here at the end, this is all just code more or less pulled straight from the NTP time examples, and it's just code that handles connecting and requesting new times from the time server. So that's it, guys. It's kind of a long program, but it should work for our purposes. And one of the awesome things about this project is that we can keep expanding it, because we didn't just go out and buy a ready-made little module. We can keep expanding it. I can put a web interface on this and make it better and better and keep improving it. So let's now go and test the whole thing out. All right, so we've built it and we've written the code for it. The last thing to do, of course, is to test it. So here's the control board. You can see I've made a couple of modifications here. I've gone ahead and added some capacitors to the relays, and that just keeps down on the ESP resetting when the relays trigger every once in a while. I did notice that the ESP, even with the capacitors I already had, would occasionally reset. So hopefully that should nip it in the bud. Now, moving outside, we can check out the valve portion of the assembly. As you can see, it is a lovely rainy day that I chose to build the sprinkler system, so not much help today. But here you guys can see the valves, and yes, they are just hanging off the spigot. Eventually, I do plan on digging a hole and putting all this assembly into the ground. But for now, and probably for the rest of the season, this will work just fine. So you can see there are the valves, and they run out via 3 hoses to 3 sprinklers on my lawn. And hopefully, this should all go well. So let's test it out and just make sure that everything works. So back at our control board here, if I go ahead and push the top button, which is my test button, you can see the relay triggered and it's on. And if we go outside, even though it's raining, we can see that the first sprinkler is running. So we have that running, and in a few seconds, this should trigger over to the middle sprinkler, and then eventually to the left-handmost sprinkler. So that's about it for this project, guys. It's a pretty cool project. It's one of the bigger ones I've done on this channel, and there we go, there's the middle sprinkler. And really, guys, it was all made possible by my amazing Patreon supporters. So these bigger projects that cost a little bit of money, I don't have that much money to put into these projects, so I really do rely on you guys. So if you want to become one of those awesome supporters, go to patreon.com/itkindofworks and just put in whatever you can. Really, every single dollar helps. And if you just want to give me a little thumbs up and let me know that you like this video, go ahead and hit that thumbs up and leave your comments below. I am looking forward to hearing what you guys have to say. All right, guys. Well, thanks for watching. I'll see you all later.